Hi, let us discuss today what are the different types of prompt engineering tools and their categories, and how each category will be helpful in the designing a task using large language models. And there are about 7 categories of tools. The first category of tools are based on the pipelines, and the second category of the tools are to design a structured output, and the third category of the tools are called validation or guardrails of the tools, and fourth category of the tools are called core declarative type of tools, and fifth category is called the experimentation tracking based tools, and sixth category is called the optimization tools, and some of them are experimental based optimization tools. And let us discuss each of this category in detail and their strength and the weakness, and that will help typically where to use these tools and how to perform your task using a large language model. Let us discuss the fourth module, which is core declarative frameworks. There are three tools in this framework. One is DSPY, which is called Declarative Self Improving Python, and LMQL, which is called Query Language for Large Language Models, and Prompt Matrix, which is a kind of A/B testing for different prompts and identifying which prompt is better. And these are the some of the framework you can use to write your prompt as a program. Let us start with the DSPY, which is a program based prompts where you can provide instructions in the form of a Python code, and the LLM act as a compiler, and you have the auto optimization engine that will divide your complex prompt into a submodules, and each modules evaluated internally using a feedback loops, and you have training loops within the auto optimization engine, and it will be evaluated using some examples and feedbacks, and that will help to improve your prompting process using declarative self improving Python, which is called DSPY. And you can define your core instructions using Python, what input you want to give, what output it has to come, and what is the process it will have to take care within your prompt. All these details you can declare, and you can use the prompts as a program in this process. And when it comes to LMQL, where you can use as a query language for large language models, which means you have more control over your tokens or logic or the constraints, and you can able to define all these constraints, logic, as well as the tokens for your prompt using the LMQL, and you can able to replace variables with values, and you can able to generalize your prompt engineering as a program. And the prompt matrix is typically used to evaluate your prompting, different types of prompting, where you can define roles, where you can define simple prompt versus the detailed prompt, and you can able to evaluate those different types of prompts and able to see which prompt is giving the better results, which is called a kind of A/B testing, where you can explore different instructions, formats, and examples, and the matrix would able to provide the evaluation of each of those prompts, and you would able to pick the best prompt among those. Please subscribe, like, comment for more technical videos on prompt engineering. There is another category of prompt tools called validation and guardrails. In this category, you can define a domain specific language driven constraints as well as the strict schema to get an output from an LLM. If it doesn't match with the defined schema, it will apply a retry logic and will attempt to get a output similar to the schema defined. And there are three tools available for this purpose. One is Guardrail AI. In this tool, you can define a heavyweight schemas, and you can define a auto retrace and validation rules. And there is another tool called Railed, where you can use a custom defined domain specific language, where you can define your own schema definitions, and it would able to match against those definitions. And if it doesn't match, it applies auto retry logic. And there is a re-LLM where you can define the validation of your output using a regular expression based patterns, and it will be a lightweight alternative that strictly forces output to match against the regular expression. The structured output and constraints comes after the validation and the guardrail process, which means that you have a defined schema that you would be getting output from LLM, And if once it matches the defined schema, you need to format the raw output of the large language model into a structured format. There are various tools you can use for this purpose. One is outline, which typically very extremely fast and deterministic, and enforces the raw LLM output into a structured format using the regular expression and grammar. Another tool is called instructor, which is a kind of a pydantic style schemas, which means that it has a Python classes. Within that Python classes, you can define the structure of your output, and you can use Python coding to get output from a prompt. There is a JSON farmer, which typically uses the JSON format to define your output, which has fields and values. And based on that fields and values, it will format your raw large language model output into a structured JSON format. And there is another tool called guidance, which is typically Microsoft's engine, combining the templating, control flow, and the constraint generation together to get your formatted outputs. Optimization and auto tuning is another category of prompt engineering process. It typically evaluates the prompts using a LLM as a evaluator and finds the best prompts that suits for a specific task, or it can able to fine tune a specific prompt from the data, and it also can benchmark with the prompt using data as well as massive prompts. So there are various tools used for this purpose. Automatic prompt engineering is typically generates the prompts and evaluates those prompts using scores, and the best prompt is selected. And the open prompt is typically used for the fine tuning of the prompts. The prompt source is basically a benchmark of the prompt from a various collection of data sets and the prompts. And there are other experimental based prompts are used. Text guards is typically used on the feedback loops, and RL prompts are used as a reinforcement learning. And there is a pro-TGA is usually used as a textual gradients to identify the prompts optimization process. Experimentation and versioning is another category of the prompt engineering process. This is typically used to track the experiments in the development system or the production ready system, especially for the ML operations. And there are two types of tools available for this process. One is prompt layer, another is weights and bias prompts. The prompt layer is usually keeps the logs and compares them and iterates on the prompts itself. And if you are going from version 1 to version 1.1 to version 1.11, then you have different logs and different metrics. You need to track those metrics and compare them in order to showcase the improvements from version 1 to 1.1. And there is another tool called weights and bias, which typically controls the versioning of different prompts as well as the different data, and also it can track the metrics used for the different versions of the prompts. This is typically useful for the managing your prompts and improving your prompts and keeping track of how the metrics have been changed when you are moving from one type of prompts to another type of prompts in the ML ops process. Lastly, we can discuss LLM pipeline and decomposition category. This category typically used for the retrieval augmented generation process. It has various stages. It has initially the input data, which is typically domain documents that will be processed and stored in a vector database, which is called retrieval and search stage. Once you prepare your domain data, you have a prompt template. Prompt template, you can write a prompt that will have a context from the retrieval or search mechanism, and you pass the context and prompt to the large language models. Large language model would able to produce an output. That output will be memorized, that will be used as a context again for the next set of prompts. This will be in a loop. So there are three types of tools used here. One is LangChain. LangChain is called as a generalistic tool that contains chain of prompts, tools, and memory. And the Llama index is typically a specialist kind of tool where it focuses on the structured flows mapping data to prompts. And Haystack is called a modular engine where prompt nodes are composed with the search pipelines. These are the three types of tools used in the LLM pipelines and decomposition. With this, we have discussed different categories of the prompt engineering tools, and we have explained in detail each category of the tools, what is the use of those category and how that will be used in the prompt engineering process. And please like and subscribe and comment for more technical videos.